In this video, we're going to be finding solutions to quadratic equations. And let's explain what we mean by that. The solution to a quadratic equation are the points at which the function intersect the x-axis. We also call these solutions roots. We'll call them zeros, or we'll call them x-intercepts. And again, we all know what an x-intercept are. This is just other names for x-intercepts. The number of solutions that we have, since we're dealing with quadratic equations, we know their graphs look like parabolas. We could possibly have two solutions, which means your parabola crosses the x-axis at two different places. We could possibly have a single solution, which means your parabola comes down and simply touches, or another name for that is tangent to the x-axis at just one place, or sometimes it might not touch it at all, and we might not have any real solutions at all. Okay, number one, let's actually solve these by graphing. We'll put our solutions over here to the left side. So let's find the solutions to each quadratic equation by graphing. And remember, first off, we're going to start out with our axis of symmetry, negative b over 2a. We're going to plug in our ab values into this, and that's going to tell us where our vertex is located and our axis of symmetry. So my b value here is 2. My a value is 1, so that's 2 times 1 is 2. So I have an x value of negative 1 for my axis of symmetry and for my vertex. So we're going to take and we're going to put that in the middle of our graph. Pick a couple of points on each side. We'll do 0 and 1 maybe, and negative 2 and negative 3 on the other side. The vertex again being in the middle. When I plug in negative 1, find f of negative 1 for your function. I have negative 1 to the second. Let me go ahead and just plug that in. Plus 2 times negative 1 minus 3. That's going to be a positive 1, a negative 2, and a negative 3, which gives me negative 4. So there's my vertex. It's located at negative 1, negative 4. Plugging in 0, you get f of 0 is 0 plus 0 minus 3 is negative 3. And plugging in 1 gives me 1 plus 2 times 1 is 1 plus 2 is 3 minus 3 is 0. And remember that we'll have that same symmetry since we went up by 1 each time. We'll have that same symmetry for the other side. So let's take and plot our points. We have the point 0, negative 3, and 1, 0. And I'm going to pause and go ahead and graph these. And here we see the basic shape of our parabola. And again, we're looking for the solutions. We're looking for the x-intercepts or zeros of this parabola, and they are located here and here. So my solutions for this quadratic equation is 1, 0 and negative 3, 0. Number 2, remember negative x squared, that you always take the negative first and then you square it. But we're going to start out with our axis of symmetry, negative b over 2a. B value here is negative 10, so that's going to be negative negative 10 over 2 times negative 1 is negative 2. So my axis of symmetry is located at negative 5. So we'll start there to find our vertex. So negative 5 in the middle. When we find f of negative 5, again, right here, make sure we take the negative first and then, or excuse me, we square it first and then take the negative. So negative 5 squared is 25. Bring down the negative. Negative times negative is a positive 50. And bring down the minus 25. And when you plug that in, it gives you negative 25. Negative 25 is negative 50 plus 50 is 0. You can pick a couple of points on each side, negative 4, negative 3, negative 6, and negative 7. Plug those values in. And here's what you're going to get. Let's see. Let's find f of negative 4. Again, we're going to square first, then take the negative. So leave the negative and square the negative 4 gives you 16. Negative 10 times negative 4 is a positive 40 minus 25. That's negative 41 plus 40, which is a negative 1. And finally, let's plug in f of negative 3. And you're going to get, leave the negative, and then square the negative 3 gives you a 9. Negative 10 times negative 3 is a positive 30 minus 25. That's negative 34 and 30, which is a negative 4. Again, this will be symmetrical about that origin, or about that axis of symmetry. Let's plot these points and connect our dots. And notice that this parabola only touches the x-axis at a single point right here, and that's going to be the solution, which is -5, 0. Now, just a real quick reminder, the reason that again was the x-intercept, remember at an x-intercept, your y value, and we learned this when we dealt with linear equations, your y value will always be 0. Very important that we remember that. Okay, the next one. Start off with negative b over 2a to find your axis of symmetry. That would be a -6, which would be 6 over 2 times 1, which is 2. That gives you an x value of 3. Let's do a t-table. X, Y, put your 3 in the middle. We'll pick maybe just a couple for each side, 4 and 5 for the other side. When you find f of 3, plug in that 3, gives you a 9, a -18, and a +8. 9 and 8 is 17 minus 18 is a -1. So that's what goes in the middle. Plug in, let's find f of 2. That'd be a 4 minus 12 plus 8. 4 minus 12 plus 8, that is -8 plus 8, which is 0. And we already know that's going to be one of our x-intercepts. So 2, 0, and we already know where our other one's going to be, but we'll go ahead and finish out our graph. Let's find f of 1, which is going to be 1 minus 6 plus 8. That'd be 1 minus 6, -5 plus 8 is 3. And let's duplicate those two on the other side, plot our points, and connect our dots. And there is our graph. And our two, again, x-intercepts are 2, 0, and 4, 0. So we did have two solutions on this one. So 2, 0, and 4, 0. And those solutions will always be, because of the symmetry, those solutions will always be symmetrical about that axis of symmetry. Next up, again, x equals -b over 2a is our starting point. Here's our b and our a values. So x is going to equal -b will be 11 over 2 times -1 is -2. Now this one's a little bit uglier because we have a decimal here for our axis of symmetry. So it's going to be -5.5. So let's do us a t-table. xy, -5.5 in the middle. Find f of -5.5. You can use your calculator if you would like. Or we could actually leave it as 11 halves there. It's a little bit easier to clean it up if you leave it in fraction form. So let's plug this in for each of our x values. Remember again here that we square first, then make it negative, and here's what you're going to get. So squaring 5.5, -5.5 gave me a 30.25, multiplied by 11 gave me 60.5, add it all together, and you get 2.25. Now let's pick a couple of points on each side. We can go up by maybe just a half, so we'll go -6, -7, and -8, then we'll step up by 1. And they can go to -5 on the other side and do -4 and -3 as well. So these should still match because I went up by a half, went down by a half, or vice versa actually, and then went up by 1 afterwards. So let's go ahead and we'll plug in the smaller values here. Let's find f of -5. Leave the negative, square the -5 will be a -25. Negative times a positive will be a +55 minus 28. That'll be a -53 plus 55, which is 2. Find f of -4. Leave the negative. Square the -4 gives you 16. -11 times -4 is a +44 minus 28. That gives you a 0. So we already have our solution there. And we can find f of -3 as well. That's going to be a -9 plus 33 minus 28, which is a -37 plus 33 is a -4. And then let's just match those exact same three values on the other side. You can plug them in if you'd like to check. Let's plot these points and see what we've got. So here's a look at our graph, and again, our two zeros are located at -7 and -4. So let's go ahead and write those down. -7, 0, and -4, 0. Number 5 equals x squared minus 9. -b over 2a gives you, there's no b value. So 0 over 2, which is 0. So therefore, This thing has just been shifted from your x squared down 9 units. So let's plug in some values, 0, 1, 2, and 3 on one side, -1, -2, and -3 on the other side. When you plug in 0, you have 0 squared minus 9. Pretty easy. Plug this one in, gives you -9. Plugging in 1, 2, and 3 gives you 1 squared minus 9 is -8, 2 squared minus 9 is -5, and 3 squared minus 9, which is 0. And then just flip those on the other side, and here's what your graph's going to look like. There you go. And your two zeros are going to be 3 and -3. That's the roots of this equation, -3, 0, and a +3, 0. Number 6. 2x squared plus 6x. First off, negative b over 2a gives you -6. Again, b is whatever's in front of x over 2 times 2 is 4. So it's going to be -3 halves. So let's do our t-table. xy, -3 halves. Let's find f of -3 halves. And again, this one you can leave in fraction form if you'd like. You can do fractions or decimals there. You could do -1.5. We're going to do 2 times -3 halves squared. To square a fraction, you square the top and you square the bottom. So it'd be 9/4. And then a +6 times a -3 halves. 2 over 1 cross cancel gives you a 2 and a 1. That'd be 9 halves. Positive times negative is a negative. 6 over 1 cross cancel gives you a 1 and a 3. That'd be a -9 over 1. Common denominator, multiply top and bottom by 2. That'd be an 18 over 2 now. 9 minus 18 is -9 over 2. So there's your vertex. So now let's plug some points in on each side. Again, this was -1.5. So let's do -1, -2, and -3 on one side. 0. Well, hang on just a second. I got those mixed up. Since that's -1.5, it'll be -2, -3, and -4 on one side. -1, 0, and 1 on the other side. Let's see. We'll start with these down here because I think it's going to be easier to plug them in. 2 times -1 squared. Let's find f of -1. 2 times -1 squared will be 2 times 1, and then 6 times -1, so plus 6 times -1, will give us 2 minus 6, which is a -4. Plugging in 0 will be pretty easy. That'd be 0 plus 0, which is simply 0. And finding f of 1, we can just modify this. That'll be 2 times 1 plus 6 times 1, which will be 2 plus 6, which is 8. So let's flip-flop that, -4, 0, and 8, and write them on the other side. Let's graph these. So there's our parabola, and our zeros are located at -3, 0, and 0, 0. So let's go ahead and copy those down. And I put those in the wrong place last time. So -3, 0, and 0, 0 was this one. The last one was -3, 0, and +3, 0. Okay, number 7. Again, we start out with our axis of symmetry, which is x equals -b. Would be -8 over 2 times a, which is -1. That'd be -8 over -2, which is 4. So let's put that on our t-table. X, y. 4 will go in the middle. When we plug in our 4, find f of -4 gives us -16 plus 32, which minus 17, and that's going to be a -1. Now let's pick some values on each side. We'll go 3, 2, and 1, and then 5, 6, and 7 on the other side. However, I don't think this is going to be necessary. We'll plot a couple of points, but we can tell right now what this solution is going to be. I'll go ahead and plug in some points and graph it, but I'll show you why I already know what the answer is going to be. So here's our t-table finished. Once we start plugging in, let's see, 4, -1 was our vertex. Now look what happens with these other points. When I graph 5, -2, we're down here. Here's the symmetrical point. When I graph 6, -5, I'm at 1, 2, 3 lower, and then the symmetrical point will be right here. Your parabola cups downwards. And that's how I knew the answer before I graphed this thing. Your vertex was below the x-axis, and your parabola cups downward. So where is this going to cross the x-axis? It will not cross it anywhere. So this parabola, the solutions, it will have no solutions. There is no intersection points for this parabola and the x-axis.